arc. Okay, yung support natin, they are both hinges. So ito yung arcs natin. Then we have the 3 hinge arc. So the support here is a hinge and this is also a hinge. Tapos dito, that is internal hinge. Then we have the tied arcs. So this is a hinge, that is a ruler, then that is connected by a tied nut or tied arcs. Okay, so we have here an example for tension in cables. Determine the tension in cables and what is the dimension H. Okay, so this is cables with concentrated load. Okay, we have here the cable connecting from point A to point B to point C and to point D. So at point B there is a load of 3 kilonewton, and at point C that is also a load of 8 kilonewton. Okay, so the spacing is 2 meters between A to B, and B to C is 2 meters, then C to D is 1.5 meter. So for the height, vertical distance of AD is 2 meters, then the vertical distance of DC is also 2 meters. Then we have here AH or H. H is the required. Okay, so if we have to consider the free body diagram of the arcs, okay, so we have here AY at saka AX. Then dito naman, we have the force T of CD, and we know the slope. The slope there is 2 vertical and 1.5 horizontal. So if you multiply that by 2, so 3 horizontal, then 4 vertical. So kaya we have here 3 horizontal at saka 4 vertical. And the diagonal is 5. So summing up moment at A equals 0. So magmo-moment tayo sa A. So we have TCD multiplied by 3 over 5 multiplied by 2. So we get the horizontal component of CD. Then the vertical component is 4 over 5 TCD multiplied by 5.5 multiplied by 5.5. So itong 5.5, that is the perpendicular distance of the vertical component. Then minus 3, itong 3 kilonewton times 2, minus 8 times 4. And that is equal to 0. So the tension on CD is 6.79 kilonewton. So since we have already now the tension on CD, then we isolate point C. So itong point C, we have 6.79, then we have tension on BC, at saka yung 8 kilonewton. So therefore, the angle on BC will be theta BC. So summation forces along x equals 0. So we have 6.79 times 3 over 5 minus TBC multiplied by cosine theta BC, and that is equal to 0. Then if we get summation forces vertical equals 0, so we have 6.79 multiplied by 4 over 5 plus TBC multiplied by sine theta BC minus 8, and that is equal to 0. So simplifying these two equations here, we will get TBC, and that will be equal to 32.3 degrees. Pag sinimplify natin itong dalawang equation dito. Okay, so we have we have the value of T of BC, that is 4.82 kilonewton. So makukuha muna natin yung TBC, that is 32.3 degrees. Then TBC becomes 4.82. Then summation forces horizontal equals 0. So 4.82 times cosine 32.3 minus TBA. So ito na ngayon, minus TBA times cosine theta BA, and that is 0. Then summation forces vertical, we have negative 4.82 sine of 32.3 minus 3 plus TBA sine of theta BA equals 0. Then equating these two equations, we will be able to get theta BA equals 53.8 and TBA is 6.9 kilonewton. Then we have H equals 2 multiplied by tangent of 53.8. So we have 2 multiplied by tangent of the angle here is yung angle dito, that is 53.8. So tangent is opposite, that is H divided by adjacent. The adjacent here is 2. So H is equal to 2 tangent of 53.8. So we have 2.74 meters. Then the next example, determine the tension in the cable at points A, B, and C. Assume the girder weighs 850 pounds per foot. Okay, so yung cable natin, the length is 100 feet. Yung height dito from point A to point B. So the vertical height is 40 feet. Then from point B to point C, we have 20 feet. Okay, so we have assumed that the point at B is located at a x distance from point C. So pag x distance dito, then we have here 100 minus x. So from the equations a while ago, yung equation natin for cables, so ito yung mga equation natin for Tmax. Okay, we have tangent theta, that is Wx over Fh. So from these equations, we have y is equal to Wo over 2Fh times x squared. So our Wo is 850 pounds per feet divided by 2Fh, multiplied by x squared. And that will be 425 over f(h) times x squared. At point C, y is 20. So 20 is equal to 425 over f(h) times x squared. So ito yung x natin. Okay, by the way, the equations here is parabolic, kaya this is in second degree, kaya naging x squared. So therefore, f(h) is equal to 21.25 x squared. Then at point A, our y is 40. And the distance is 100 minus x squared. So from the equation, 425 over f(h) multiplied by negative 100 minus x quantity square, and that is equal to 40. Then simplifying the equation, it will lead to quadratic equation, wherein x squared plus 200x minus 10,000 is equal to 0. So therefore, x is equal to 41.42 feet. So nakuha na natin yung value ng x, that is 41.42 feet. So therefore, our f(h) is 21.25 x squared. So 21.25 multiplied by 41.42 squared, and that is 36,459.2 pounds. Then from dy over dx, so ito yung dy over dx natin. Tangent of theta is dy over dx, that is wx over fh. Okay, so we have dy over dx is 850. 850 is the uniform load multiplied by x divided by fh. So 850 times x divided by 36,459.2 x. So at point A, x is negative 58.58 feet. So tangent of theta A is equal to dy over dx, wherein x will be negative 58.58. So we have 0.02331 multiplied by x, that is 58.58, and that is negative 1.336. Therefore, theta A is negative 53.79. Okay, so then using equation 5.4, TA is equal to FH over cosine theta A. So 36,459.2 divided by cosine 53.7, and that is 61.7 kips. So the unit here is kips, or that is kilo pounds. At point B, x equals 0. So tangent theta B is equal to dy over dx is equal to 0. So therefore, theta B is equal to 0. Then the value of TB is FH over cosine theta B. Then cosine of theta B is cosine of 0. So that is 36,459.2 pounds or 36.5 kilopounds. Then at point C, x is 41.42. So tangent of theta C is dy over dx, wherein x is 41.42. So we have 0.02331 multiplied by 41.42, that is 0.9657. So theta C is equal to 44 degrees, or this arctan of 0.9657. So theta c or Tc is equal to Fh over cosine theta c. So 36,459.2 divided by cosine 44. So we have 50.7 kilopounds. Okay, so let's have the next example. Determine the internal forces at section D. Okay, we have here a 3-hinge arc. So 3-hinge arc ito. We have point A, point B, they are a hinge. Then point C is internal hinge. Pero ang tinatanong is at point D. What is the internal forces at point D? So meron tayong the normal force, the perpendicular force or the tangential force, at saka yung moment dito sa point D. So if we take moment at point A equals 0, so 10 times 10, 100 times 10 plus 60 times 28 minus B sub B multiplied by 40, and that is equal to 0. So we have B sub B B sub B ginamit dito, but that can also be B sub Y. Pwede rin B sub Y. So B sub Y is equal to 67 kilonewton. Then, if we isolate at the right, yung right portion ng arc, so that will be from point C to point B. So from point C to point B, we have B sub B or B sub Y multiplied by 20 minus 60 multiplied by 8. The perpendicular distance is 8 minus HB or BX multiplied by 10 is equal to 0. Or this is now the equation. Negative BX multiplied by 10 minus 60 times 8 plus 67, itong reaction ng BRB multiplied by 20 equals 0. So B sub X is 86 kilonewton. So therefore, we can now determine the reaction at point A. So summation forces horizontal equals 0. So therefore, AX or HA, that is equal to 86 kilonewton. Then summation forces vertical, we have 160 minus BB or BY minus 67 and that will be equal to AY or B sub A. So we have the reaction now at, or the vertical component of the reaction at A is 93 kilonewton. Okay, so we isolate the right portion on the left portion of the arc with the point D. So kinuha natin between point A to point D. So at point D, mayroon tayong component of the reaction. So So the component of the reaction here is in-isolate natin sa point D, kinat natin, so we have 93 kilonewton yung vertical component. So that is summation forces vertical, we have 93. So 93 ito. Then if we take summation forces horizontal, this is 86. So mayroon din tayong 86 dito. Okay, so the angle at point D is 20 degrees. So naka 20 degrees dito with respect to the horizontal. So meron tayong 20 degrees. So therefore, we have the component of the forces, yung tangential component of 93, we have 93 sine of 20. Normal component rather. Then the tangential component of 93 is 93 cosine 20. So since yung 93 downward, therefore the component that is also pababa. Then for the 86, the normal component is 86 cosine 20. So yan yung normal component niya. And the tangential component, that is 86 sine of 20. Okay, so pag kinuha natin yung tangential at saka normal component, we have 93 sine of 20 plus 86 cosine of 20, that is 112.6. Then the tangential component is 58, 93 cosine of 20, downward siya, then minus 86 sine of 20, and that is 58. So 58 yung result dito. Okay, so meron din tayong moment dito. So the moment here will be by taking moment at point A, or pwedeng dito tayo mag-moment. We take moment at this point. So dito tayo mag-moment. So summation moment at A, that is equal to 86 multiplied by 8 minus 93 multiplied by 10. And that will be 242. Okay, so the normal component is 58. So yan yung normal component niya, 58. And the tangential component is 112.6. And we have the moment at D is 242 kilonewton. Okay, so this is now the remaining. There is still one topic to be discussed. Okay, meron pang isang topic, and we will discuss that on Wednesday. So sa Wednesday ko i-discuss yung last topic. Ang last topic natin is plane frame. So meron pa tayong isang topic, and that is plane frame.